Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on November 26, 2025, about 3 days ago. It introduces ViLoMem, a dual-stream multimodal semantic memory that lets multimodal large language models avoid repeating visual and logical mistakes, with gains like plus 6.48 points on math vision for GPT 4.1 and plus 4.38 points on MMMU for QN 3V L8B. The paper is titled Agentic Learner with Grow and Refine Multimodal Semantic Memory. And as we will see later, the implications for how agents learn from past successes and failures are quite significant. Figure 1 illustrates how multimodal semantic memory lets an agent progressively learn from its visual and logical mistakes. The sequence of robot and human panels shows initial wrong attempts at a triangle area problem, where the agent both miscalculates and misreads the diagram. Through feedback, the agent stores abstract math rules in a logic memory and common visual traps in a visual memory. On later problems, the agent retrieves both memories, which guides where to look in the image and how to reason correctly, so its final answer becomes accurate and confident. Figure 2 spells out how ViLoMem actually runs as an agent that learns from its own multimodal mistakes. The left panels describe a memory cycle, where logic and visual memories are retrieved together, used by the solver, and then checked by a verifier that decides when to grow or refine memory. The middle block focuses on memory generation, which attributes errors to either reasoning or perception and merges similar guidelines. The right block presents memory retrieval, where text drives logic retrieval while both image content and question text steer visual retrieval, producing attention heat maps that show where the agent should look. Table 1 summarizes how the grow and refine semantic memory raises accuracy across 6 multimodal benchmarks. For GPT 4.1, accuracy on MMMU increases from about 74 to about 77, showing that memory adds value beyond step-by-step prompting. Math vision scores for this model rise from roughly 46 to about 54, which matches the strong visual grounding gains the authors highlight. The two QN3 vision language models also see consistent boosts, especially on MMMU and MM star, so the memory framework helps both large and smaller systems. Table 2 tests which parts of the dual-stream memory actually matter for GPT 4.1. The table shows that removing logic memory or removing visual memory both lowers accuracy on MMMU and Math Vista, so each stream captures different useful errors. When both memories are active, scores rise to about 77 on MMMU and 77 on Math Vista. Adding visual attention maps pushes MMMU slightly higher again, while Math Vista stays roughly unchanged. Table 2 tested which memory components matter most, and Figure 4 analyzes how the two streams are actually used across benchmarks. The left panel shows that most stored errors are visual, which means perception remains the main bottleneck, yet retrieval happens much more often than memory creation. The right panel plots visual versus logic usage and places most points near the diagonal, so retrieval draws on both streams in a balanced way across models and tasks. Table 3 asks whether one model can learn from another model's mistakes by reusing its stored memories. The table lists 3 solvers and compares their own ViLoMem memories against cross-model memories on MMMU and Math Vista. Larger models like GPT 4.1 change only slightly with cross-memories since their self-memories are already strong. The 8 billion parameter QN model gains the most, reaching about 71 on MMMU and 79 on Math Vista, which shows that weaker models benefit from distilled error patterns produced by stronger peers. Alright, to wrap up, 2 takeaways stand out. ViLoMem turns multimodal models into true agents that remember where they missaw and how they misreasoned, and this dual visual plus logic memory reliably boosts accuracy across tough real-world benchmarks. Longer term, this kind of semantic memory looks key for lifelong cross-model learning. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.